Let's think of the brain as a bookshelf. New books are not constantly created. Instead, existing books are moved to different positions. As connections shift, entirely new stories emerge. In this sense, memory and learning in the brain are closer to changes in arrangement than to replacement. But this rearrangement is not random. Frequently used paths, LTP, become stronger, while rarely used paths, limited, grow weaker. In other words, synaptic strength changes. When there are more doors, movement becomes smoother, that is, the number of receptors is regulated. When a connection is maintained over time, the structure that holds it becomes more stable, that is, the shape of the spine changes. Rather than endlessly adding connections, the brain focuses on removing unnecessary ones, that is, axonal pruning takes place. Too much excitation leads to chaos, and too much inhibition brings everything to a halt. So the brain balances excitation and inhibition to prevent overload. The brain follows these selection criteria precisely, preserving some connections while discarding others. As these changes accumulate, the flow of information across the entire network shifts. If the brain relied on regeneration rather than rewiring, it would be impossible to preserve memory while adapting to change. Change everything, and identity collapses. Change nothing, and learning stops. Humans are meant to live by thinking. Through a structural design based on rewiring, we are able to pass through life beyond the level of insects, without collapsing under the weight of our own minds.